Good morning students. Our next experiment is calculation and verification of impedance and current of RL, RC and RLC series circuit. So basically impedance ante enti ante impedance means it's a combination of resistance and reactive elements. Okay, so reactive elements మనకున్నది two elements, ఒకటి వచ్చి ఇండక్టెన్స్ ఇంకొకటి వచ్చి కెపాసిటెన్స్. సో ఈ కెపాసిటెన్స్ అండ్ ఇండక్టెన్స్ కాంబినేషన్ విత్ రెసిస్టెన్స్తో అది కూడా సిరీస్లో ఫామ్ చేసినటువంటి సర్క్యూట్ ఏదైతే ఉంటుందో దానికి మనం ఇక్కడ ఇంపెడెన్సెస్ని క్యాలిక్యులేట్ చేయాలి. ఫస్ట్ థియరిటికల్గా ఏ విధంగా మనం ఇంపెడెన్సెస్ని క్యాలిక్యులేట్ చేస్తామో చూసి దాని తర్వాత ప్రాక్టికల్గా సేమ్ అదే వాల్యూస్ మనకి సర్క్యూట్లో వస్తున్నాయా లేవా అంటే ప్రాక్టికల్గా మనం వెరిఫై చేస్తాం అనమాట. సో ఇక్కడ ఫస్ట్ వీఆర్ గోయింగ్ ఫర్ వెరిఫికేషన్ ఆఫ్ ఇంపెడెన్స్ అండ్ కరెంట్ ఆఫ్ ఆర్ఎల్ సర్క్యూట్. సో ఆర్ఎల్ సర్క్యూట్ ఇన్ ద సెన్స్ వీఆర్ గోయింగ్ టు టేక్ వన్ రెసిస్టెన్స్ అండ్ వన్ ఇండక్టెన్స్ and we are going to connect these series combination to a power supply. So theoretically here we are going to take a 10.5 volts. So according to our circuit we are going to take a 10.5 volts for input and resistance here 1 kilo ohms and 100 millihenries inductance. For this circuit we are going to calculate the impedance value. Okay, and this is a practical diagram. So nothing there is no any difference between theoretical and practical circuit diagram. Just we are taking one ammeter to measure the current, whatever the current flowing through this circuit, that current we are measuring by using this ammeter. Okay, so practically we are taking current value directly, but this current we are going to calculate theoretically by using different formulas. So here we are going to take theoretical. So here impedance for RL circuit in the sense, so Z is equal to root R square plus X square. This is the actually formula for impedance. So here impedance is, it's a combination of resistance and inductance. So here we are taking Z is equal to root R square plus XL square. Already we know that formula. Okay, but here we know resistance only. So what is the resistance here? 1 kilo ohm resistance, but we don't know XL value, it's mean reactance value. So that reactance we are going to calculate by using XL is equal to 2 pi FL. So according to our Indian standard, here frequency F is equal to 50 hertz and inductance given in circuit 100 millihenries. That 100 millihenries we are going to substitute here. Then we are going to get value here, XL value. So I have calculated already. So according to our circuit values, so 2 pi, so F is a 50 hertz according to our Indian standards, frequency is 50 hertz and that is equal to we got 31.41 ohms. So that one is the reactance. So reactance units only we are going to take ohms. Okay, so already we know that resistance value is 1 kilo ohm in a circuit. Okay, and here inductance is 10 millihenries. So this one is not a 10 millihenries actually. So this one is a 100 millihenries. By mistake I have written. So you have to see this one is a 100 millihenries. So already you know that one 100 millihenries. And here V is equal to 10.5 volts we are taking here. So according to that we are going to calculate here. So why here we are we were taken we have taken a 10 to the power of minus 3 in the sense. So this one is a millihenries. So that's why 100 into 10 to the power of minus 3 we have taken. So here Z is equal to root R square plus XL square, that is equal to, already we know that resistance is 1 kilo ohms. So 1 kilo in the sense 1000 whole square plus, and already we calculated XL value, that one is 31.41. So we substituted here 31.41 whole square. So according to that we got impedance value Z is equal to 1000.49 ohms. And current in RL circuit in the sense I is equal to V by Z. Already we know that the formula for according to Ohm's law I is equal to V by R, but R place we can replace the impedance, okay, because here we are not taking not only a resistance and as well as we are taking inductance also. That's why we are taking I is equal to V by Z. So V already we know that one is a 10.5 volts, and recently we calculated Z value, so that one we substitute in the sense we got current value 0.010 amperes. So here in RL finally we calculated Z value 1000.49 ohms and current value I is equal to 0.010 amperes. Okay, this one is a RL. And then we are going for next one RC. It's mean resistance is common, but we have changed here inductance place we are taking capacitance. So that capacitance also we are taking here 10 microfarads. So micro in the sense 10 to the power of minus 6. Okay, so those values also we are going to substitute here in our formula. So for capacitance we are going to take XC value is completely different. So that XC value is, this one is a theoretical circuit diagram, and here this one is a practical diagram. Same like previously we have taken on ammeter now in series with resistance and inductance, but here in series with resistance and capacitance we are taking one ammeter for measuring the current value, whatever the current flowing through this circuit. Okay, and here according to our theoretical calculations, so previously Z is equal to root R square plus XL square, but here we have taken capacitance, that's why we are taking here XC square. So XC formula, I mean reactance formula, so for capacitance 1 by 2 pi FC. Previously we have taken for inductance, that one is 2 pi FL, but here XC is 1 by 2 pi FC. So according to this we are going to take 1 by 2 pi. Already we know that according to our Indian standard frequency is 50 hertz, and C is already we have taken here 10 microfarads. So 10 into 10 to the power of minus 6, because micro in the sense 10 to the power of minus 6. So we got XC value is 318.30 ohms. So that one we are going to substitute in impedance. We got 1049.43 ohms. Okay, finally we got from this RC circuit impedance Z is equal to 1049.43 ohms, and current I is equal to same previously whatever the current we got in impedance RL impedance 0.010 amperes. Here also same in this RC circuit also we got same only impedance only have changed, and remaining current is same I is equal to 0.010 amperes. Okay, then we will go for combination of 3. It's mean verification of impedance and current of RLC circuit. So it's mean theoretically we are going to take resistance, inductance and capacitance. So previously we have taken only 2 combinations. One is a resistance and inductance, another one is resistance and capacitance. Here we are taking a combination of 3. Okay, so already whatever the values we have taken previously in RL and RC, the same values we are taking here, 1 kilo ohms and 100 millihenries and 10 microfarads. The same values we are taking here for a 3 combination also. This is a theoretical circuit, and same here extra one element is there. So in RL there is no capacitance, in RC there is no any inductance, but here inductance and capacitance both are present in this circuit. So that's why here we are taking R is equal to 1 kilo ohms, that one is 1000 ohms, and L is equal to 100 millihenries, in the sense 100 into 10 to the power minus 3 milli we are converting into 10 to the power minus 3, and capacitance we are converting micro into 10 into 10 to the power minus 6 farads. And here this one is a practical diagram. The same thing in 2 combination also we have taken in series 1 ammeter, and 3 combination also we are taking in series 1 ammeter, and theoretically we are calculating here. So according to here in a 3 combination, our formula is, impedance formula is Z is equal to R square plus XL minus XC whole square. So according to that, XL we already calculated in RL circuit, that one is 31.41, and XC also we have calculated, that one is 318.30. so these 2 values we are going to replace here. No need to calculate once again, already we have calculated XL value and as well as XC value in previous conditions. I mean to say that in RL and RC combination case, we have calculated XL and XC values. Those 2 values directly we are going to substitute here. If you have any doubt in the sense, you have to refer that RL and RC circuit theoretical calculations. And here we are going to substitute all the values. We got impedance value is Z is equal to 1040.33. so in all the cases you observe impedance value is 1040 or 1039 like that only. So it's mean little bit vary only, but it's more than 1000. Okay, so here also current is same in all the circuits. Whatever the impedance, it will be going to vary, if maybe in RL and RC and RLC, but most of the cases we got approximately same current only, because here you observe previously also in XC Z condition 1049. In first case also impedance we got just 1000. The difference is just a 40 ohms only. Okay, and compared to here also same. This one is 40 and previously this one is 49. Just 9 ohm difference only. So that's why only there is no any much more difference in impedance calculation. That's why we got almost current is same in all the circuits. That one is I is equal to 0.010 amperes. Okay, so those theoretical values we kept in a tabular column. So these are the theoretical values and these are the practical values. So in RL circuit, what is the impedance and what is the current, and RC circuit, what is the impedance and what is the current. So already I have written in end of the theoretical calculation both impedance and current values. So those values you have to replace here. RC circuit, so Z value and current value, and RLC circuit, what is the Z value and what is the current value. So in all the conditions current is same. So practically we are going to see what will be the current values we will be going to get if we are going to connect the circuit in RL and RC and RLC. Let us wait and see. We are going to connect the circuit and we will take practical values.